Imagine an autonomous small spacecraft heading to explore a near-Earth asteroid, map it at close distance, land, and roam its surface, all on its own with only limited guidance from Earth. After launching on a commercial rocket, the spacecraft separates, stabilizes itself, and autonomously checks out its instruments, sensors, thrusters, and antenna before it embarks on the one-year journey. It cruises autonomously to its destination, navigating by using sightings of distant asteroids with its optical navigation camera. At its first sighting of its target, the spacecraft locks its gaze onto the faint-looking body from hundreds of thousands of kilometers away, refining its own location and that of the body as it approaches. With its narrow and wide field of view cameras and powerful onboard computing, DARE starts discovering this unexplored asteroid. DARE estimates the body's rotation rate and uses its dancing silhouette to construct its shape and axis of rotation. As the images of the asteroid grow and show more detail, the spacecraft identifies and tracks surface landmarks, refining its understanding of the body's motion and shape. As it gets closer, the spacecraft reaches a hover point, turns on its near-infrared spectrometer, and starts its scientific mapping of the asteroid. Tracking its progress, it shares an initial assessment of the near-Earth object's maps and composition to the scientists back on Earth. Building a high-resolution global elevation model of the body, the spacecraft identifies possible landing hazards and candidate landing sites to send to the ground for further evaluation. Based on science and engineering information, scientists make the final decision on the landing region. Once a landing site has been confirmed by the ground team, it is time to head to the surface. DARE readies itself for its surface mission and starts its descent, controlling its trajectory and attitude toward the target to minimize rebound, streaming data to the ground for later analysis. After a sequence of anticipated bounces, the spacecraft is now ready to start exploring the surface. It self-rights and images its surroundings, establishing situational awareness. X-ray spectrometer measurements determine elemental composition for ground-truthing orbital maps. The spacecraft charges its batteries and hops to its new destination, looking back to image the patch it departed to understand surface properties. The Deep Space Autonomous Robotic Explorer, DARE, demonstrates a new paradigm in planetary exploration that handles uncertainties of an unknown world across mission phases. It is a stepping stone to more remote and extreme destinations on moons in the outer solar system that might host extraterrestrial life.